All right, in this video, we're just going over average rate of change. Again, back earlier in middle school and in pre-algebra and algebra 1, you learned the slope formula, which was y2 minus y1 over x2 minus x1. Well, we used that because we said that there was a constant rate of change, so we referred to it as a slope on the linear function. On a nonlinear function, we can't say that the slope is representative of the entire function because a nonlinear function changes directions, and therefore the slope changes as you go between two different x values. So it's not a consistent rate of change like a linear function is. So when we look at doing the average rate of change, we're still doing the slope formula. We're just kind of phrasing it a little bit different, displaying it a little bit different. That way we don't write down the letter M to represent it. We would say the average rate of change is what we would go through and do. That's how, instead of writing the letter M. So in this first two examples, I actually have linear functions. So just to show you that it does match up on the process, here my slope is technically 7. Now we're going to go ahead and use the formula to kind of figure this thing out. I have to figure out what f of x2 and then what that is. So that'd be f of 4, which gives me 7 times 4 minus 2, which is 26. And then f of x1 would be f of 1, which would be 7 times 1 minus 2, which is 5. So I have ordered pairs of 1, 5 and 4, 26. And then now I'm going to plug them in. I know what they are. I'm going to plug it into the average rate of change formula. So 26 minus 5 over 4 minus 1 would be 21 over 3, which is 7. And so we would say that the average rate of change, change is 7 units per whatever. We don't know what the x value is, but it's 7 whatever the y value is in context. If we're talking about a word problem, per something. Next one, we would go through the same thing. I see that I have a slope in this linear function. This slope is -8. So we're going through the same process. We got to find f of x2. So that's f of 0, which is -8 times 0 plus 5, which is 5. Then we're going to go through and do f of x1, which would be f of -2, which is -8 times -2 plus 5, which is 21. So now as we set this up, it would be 5 minus 21 over 0 minus a minus 2. That's a -16 over 2, which is a -8. And hey, we match what we have up there. All right, now we start getting into a nonlinear function. Still going to do the same process, trying to find the average rate of change. As we look at this example, this is the square root graph. And the typical y equals x squared graph starts at the origin, and then it's a slow curve up to the right. Now, this one has a little bit of shifting taking place here. I believe it's like shifted just a smidge to the right because of that 2. It'd actually be like at 1/2 for an x value, and then it would be the same kind of layout here. Again, just giving you an example of showing that, hey, this is not linear, so it's going to change. We're trying to figure out, okay, what is the average rate of change between this point at x is 1 and this point where x is equal to 5. We're trying to figure out, well, what is that average rate of change between those two areas? So, same process. F of x2 would be f of 5. So that would be the square root of 2 times 5 minus 1, which is the square root of 10 minus 1, square root of 9, which is 3. And then f of x sub 1 would be the square root of 2 times 1 minus 1, square root of 2 minus 1, which is square root of 1, which is 1. So as I set up my average rate of change formula, it'd be 3 minus 1 over 5 minus 1, which gives me 2 over 4, which is equal to 1/2. So there's a roughly, the average rate of change between those two x values is about a half, is what it is, 1 unit over 2. Here we have a parabola that opens down because I see the x squared. So this one would be shifted down 5. And then it would be a really narrow parabola because of the 5, and it opens down because of the negative. So this is what my graph would look like. And then I'm trying to figure out, well, what is the average rate of change between when x is -1, so that's this dot right here, and then when x is equal to 4, which could be like way over here, just because of how the scale of what we're doing here. So we're trying to figure out, well, what is that average rate of change? Now, what we're doing here when we're finding the average rate of change, we're actually finding the slope of the secant line is what we're finding the slope of. And then that's a term that we popped up in class and talked about it. So now let's go through. F of x2 would be f of 4. So that would be -5 times 4 squared minus 5. What does that give me? That gives me -5 times 16 minus 5. That's -80 minus 5, which is equal to a -85. All right, just going to go double check my math just to make sure. 16, that's a -80. And then that, yep, that looks good. And then f of x1 would be -5 times -1 squared minus 5. That's -5 times 1 minus 5. That all works out to be a -10. So setting up my average rate of change, -85 minus a -10 over 4 minus a -1. That's -85 plus 10 over 5. That works out to be -75 over 5, which is a -15. So the average rate of change between those 2 points is about -15. Makes sense to me. It's very steep in here. It's a very steep slope between those 2 points. Also, it's going down from left to right, so I should get a negative answer as we're doing this one. Again, hopefully this helps. And again, just remember, average rate of change, just a fancy way of finding the slope between 2 points. We just don't refer to it as the slope. We refer to it as the average rate of change because we're typically working with nonlinear functions.